Hello students, welcome to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem from Vector Mechanics for Engineers by Beer and Johnston, and the problem says that a telephone cable is clamped at A to the pole AB, knowing that the tension in the left hand portion of the cable is T1 equals to 800 pounds. So this T1 is given, which has a magnitude of 800 pounds. We are required to determine by trigonometry the required tension T2 in the right hand portion if the resultant R of the forces exerted by the cable at A is to be vertical. So we have to find T2 value in order to have the resultant in the vertical direction, and we have to find the corresponding magnitude of the resultant as well. So now we have to draw a free body diagram. So let's say that this is somewhere here is my point A, and let's say that T1, which is acting at 15 degrees, let's say this is my T1, let's say this is T1, and it is given that it is acting at 15 degrees with the horizontal. Now the sum of this T1 and T2 must be vertical, so the vector sum of T1 and T2 must be a vector which needs to be vertical. So I need to add T1 plus T2 by head to tail rule. So this will be let's say this is my T2, this is my T2, and the resultant of both of these will be from the tail of T1 to the head of T2. So this is my resultant, and which is vertical, which is in the downward direction. So now we know we are given that T2 is making 25 degrees with the horizontal. So now we can say if this is my, let's see, this vector is my T1, this is my T2, so this is that same T2 vector. So if we look into this, so this T2 must be making that 25 degree angle here. So let me draw a horizontal line here. So this angle is 25 degrees. This is given in this diagram. This is 25 degrees. And as we can see that if this is horizontal line and if this is horizontal line, so this angle and this angle, both of these angles are equal, since both of these angles are alternate angles. So we can say that this is 15 degree angle as well. So now 15, this 15 plus 25, this is 40 degree angle. So we can say that 15 plus 25, this is 40 degrees. So this means that the angle between both of these vectors is 40 degrees when they are joined by head to tail rule. So T1 is given, the magnitude of T1 is 800 pounds. Now if we look into this resultant, it is vertical, so it's going to make 90 degree here. So if this is 90 degrees and this is 15 degrees, then we can say that this angle is 90 minus 15. So 90 minus 15 is 75. 90 minus 15, this is 75. So this is 75 degree angle. Similarly, let's say if this angle is, let's say, angle theta, so we can find this angle theta is, we know that the sum of the angles of a triangle is always equal to 180. So we can say that theta plus 75 degrees plus 40 degrees, this must be equals to 180 degree if all these three vectors are making a closed triangle. So then theta is equal to 180 minus 75 minus 40. So 180 minus 75 minus 40, this gives me 65 degrees. So theta equals to 65 degrees. Now we can find T2 if we apply the law of sines. So let me apply the law of sines, and we can write that T2 divided by the sine of the opposite angle. So the opposite angle to T2 is 75 degrees. So sine of 75 equals to T1. The magnitude of T1 is known, that is 800, divided by the sine of the opposite angle. So the opposite angle is theta. So sine of theta, theta is 65. So sine of 65. And now if I multiply both sides of equation by sine of 75, so we will have T2 equal to 800 sine of 75, and this will cancel out. So T2 is equal to 800 sine of 75 divided by 800 sine of 75 divided by sine of 65, and this gives me 852.62, or we can say that T2 is approximately equal to 853 pounds. So if the magnitude of T2 is 853 pounds and if it is acting at an angle of 25 degrees, then the resultant must be vertical in the downward direction. Now we can find the resultant magnitude again by applying law of sines. Now this time we can say that R divided by the sine of the opposite angle. Now the opposite angle is 40. This is 40, so we can say that R divided by sine of 40 equals to again T1. So that is 800 divided by sine of the opposite angle, which is theta. So sine of 65 degrees. And now again multiplying both sides of equation by sine of 40 will cancel out and we will be left with R. So we can say that R is equal to this. So R is sine of 40, 800 into sine of 40 divided by sine of 65. This is approximately, R is approximately equal to 567 pounds. So this is the solution of this particular problem. I hope it will help you in your learning. Let me know in the comments if this helps in your learning. Do subscribe Engineers Academy for such more problem solutions from Vector Mechanics by Engineers. Vector Mechanics for Engineers by Beer and Johnston.